Okay, thank you. If I get too loud, then somebody let me know, because I've got a couple things going against me. One is all these wires, and two is allergies, and I've about lost my voice. So I'm not sure how loud I'm screaming. All right, so in the field, I'm gonna go hunt my water down. In the field this morning, we got to do a little bit of hands-on, and we didn't really get into the nuts and bolts of the whole solution of temporary fencing for managed grazing. And there's probably about as many ideas and as many methods for managed grazing when it comes to fencing as there are that people that actually apply the practice. So what we're going to do for the next 30 minutes or so is just talk about some of the basic concepts and some of the tools that you can use to help change the dynamics on your operation when it comes to controlling your animals. And so first of all, how many of you all have cattle? All right, how many small ruminants? Horses? Anybody doing mixed species? All right. So I'll try to keep that in mind. My wife and I, we're cattle producers over in Muhlenberg County. So a lot of what I talk about, if I don't catch myself, I constantly refer to when we go to a cattle application. So I guess getting started, when we think about electric fencing, whether it's permanent like we use today, or temporary like we use today, or the permanent fencing that you saw around some of the cross fencing, we have to remember that electric fencing, that power fencing, is a psychological barrier. And we learned many years ago that multi-strands of smooth high tensile wire in a permanent application without electricity on it was not a very good physical barrier. So when we think about physical barriers, you think about wood fence or plank fence, woven wire, barbed wire. Those are all designed to physically keep animals from pressuring the fence. It took about 10 years or so after that non-electrified high tensile concept hit the U.S. to realize that we could take about half as many of those strands, electrify them, and have a very effective psychological barrier. And what we know about those psychological barriers is that we can go to just about any zoo in the U.S. and most of them around the world, and we can find electric fencing, the psychological barrier, made up of the same tools and products and accessories that you would use for a permanent situation. We can find those same tools and concepts used at zoos. And in most cases, that is the primary barrier to keep these animals away from that decorative big wrought iron fence or the moat or the cables that are between you and these wild animals. So if we can use electric fencing as a primary barrier to control these animals, then why in the world can we not effectively use that same concept to control these animals? And the fact is that we can. We just can't take the wrong shortcuts, because as livestock producers, we will like to take shortcuts, right? And there's some shortcuts we can take and there's some we shouldn't take, and we'll talk about some of those later. But the fact is, with temporary fencing, like we used in the field today, that we can completely change the dynamics of our farm, whether it's in nice spring pasture, and you can see here single strand polywire, or in dirty brown stockpile fescue while the neighbors are feeding hay in December, single strand. And that's all it takes, as long as we build the rest of the system right and train our animals to it. So at the end of the day, who's making the decisions on your operation? Are you the one making the decisions, or are your animals making the decisions? And typically we think about some of the set stock operations, or continuous grazing, where we just open all the gates, let the animals roam wherever they want to. Then that gets into a whole other system of problems of weeds taking over and desirable plants slowly disappearing. We can change those dynamics with simple temporary fencing. And this is very simple, and you saw it today. Most of what you need, with the exception of the corner post, because those 1-inch fiberglass corners, those are pretty specific for our application in the field, because we do have 8 groups of cattle side by side, so we wanted some substantial corners. But for the most part, you can pack everything you need in your arms walking across the field to do some type of managed grazing. Now, granted, there's a lot of technology in solar energizers today, but other than that, it's low tech. I mean, all you have to have is a reel, an arm load of post, and some type of power source, whether it's a solar energizer or whether it's an offset fence that's powered from a 110-volt charger somewhere on the other side of the farm. So it's very, very, very simple. A couple things to keep in mind. We can have mistakes, and we do see mistakes. And the most common mistakes are not enough power on the fence because it's a psychological barrier. The animals have to feel the shock. They have to be trained to it for them to respect the fence. Improper grounding. It doesn't matter if it's here in Kentucky or across the world in 130 countries where the folks I work for do business at. Grounding is always the number one place that we go to look for issues when we're on a farm call. And also using the wrong type of wire for the application. And we'll get into that in a second. And that would be color and material and the blend of both of what type of material is in the wire. And animals have to be able to see it for it to be effective. And that goes for wildlife too. I've heard over the past 17 years or so of doing this, I've heard many times, well, I can't use temporary fence. I just have to let the cows go where they want to because I can't use temporary fence on my farm because the deer just tear it down. And the fact is, if the deer can see it, they can respect it, because I guarantee you in some of the places in Kentucky where we have some of the most aggressive and ambitious grazers just happens to be in some of the places where we have the highest deer densities in the state. So if deer can see it, they can respect it. And they will try to avoid the fence, whether it's going over the fence or shooting under the fence. So ground system, again, this is the most overlooked part of the fence, of the system as a whole. So what is a good ground system? This isn't just my idea or the folks I work for. This is also agreed upon by NRCS in most every state and Extension in most every state. So the rule is, or the general recommendation for a permanent system, so if you're going to leave your energizer in any one place for any period of time longer than a week or two, the general recommendation is 3 ground rods, 6 foot deep, 10 foot apart. Now, if you're moving a solar energizer every time you move your reel of polywire, then you can get by with 1 ground rod, because we're not reaching out across the farm to pick up that shock like we are with a larger involved system, because that ground rod is your antenna. It's reaching out to pick up the signal when the cow touches the fence or the sheep or the goat tries to go between the wires. So 3 ground rods, 6 foot deep, 10 foot apart. Use 1 wire to connect them all. And also the general recommendation is to use galvanized. We want all the materials to be the same. We don't want to mix copper and galvanized ever. Copper is a great conductor, but copper does not like other metals. When you mix copper and galvanized together, electrolysis occurs because you're running electricity through it, and you can have your copper wire eat the galvanized wire up. And so you say, okay, I use a copper ground rod and a copper wire. Everything's good, right? It is until you go to the energizer terminal. If the energizer terminal is not copper, it'll just corrode your energizer terminal. The terminal on your fence box, it'll corrode it right into. So stay away from copper. One thing to remember is when an animal touches the fence, this is an all hot fence, example, 3 strands. When an animal touches that fence, the electricity is flowing from the wire down through the animal's body, through the feet, back through the soil, to the ground rods. These ground rods get hot. When an animal touches the fence, it's just a split second, but those ground rods actually get hot. Total different concept than the ground rod that's attached to this building. The ground rod on this building is for safety reasons. This ground rod does not have electricity flowing through it every time you flip a light switch. It's to divert power in case something goes wrong. The ground rod on this fence system is actually to cause the animal to get shocked, and therefore the ground rods do heat up and they do conduct electricity. That's why we want to stay away from copper. And that's why we can use copper ground rods on this building for the electric service, and it'd take a long time for it to corrode or for electrolysis to happen in the breaker box where everything's connected together. So you see what's going on here. We're completing the circuit, and this ground system is picking up the signal. This is our antenna. The bigger the antenna, the further across the farm we can reach the goat or the sheep or the cow or the horse or neighbor's kid or whatever's touching the fence. So selecting power. There's a few reasons why we want to select enough power, maybe even more power than what we need, because we want to have some in reserve, because we know what happens this time of the year. We think everything's good right now. We go out and check our fence. The voltage is just about right, maybe 5,000, 6,000 volts. It's controlling the animals. And then at the first week of May, after this cold spell is over, then the grass is going to shoot up. We're going to have all those succulent weeds touching the bottom strand of our permanent high tensile fence, and it's going to start drawing the power down. That's why you want to have a little extra power in reserve. As a matter of fact, if you do have extra power in reserve, it will dehydrate the grass. And when you go back out to the farm tomorrow to evaluate your pastures, if you look at the cross fence that is directly in front of you when you walk through the gate, which will be on the back side of your pastures, you'll notice that bottom, it's 3 strands of electric high tensile, that bottom strand, you can already see the grass turning yellow. So it's not burning the grass, it's dehydrating the grass. Because at the research center, they do have enough power on that fence to have some in reserve, and they're using that reserve right now to dehydrate the grass. So it's not going to burn it, it's not going to catch it on fire. Modern technology from every company is pretty much low impedance now, so it's not going to get hot and start grass fires. So saving time, chasing shorts, also from just general peace of mind, because if we can have confidence in our fence, we know our cattle or livestock are where they're supposed to be. So power supply options. Really the main point I want to drive home here is you've got 110 volt, you've got battery, and you've got solar. 110 volt is always going to be the cheapest power per joule, or cheapest dollar per horsepower, because we're buying horsepower. And solar is always going to cost more per horsepower or more per joule. Because with solar technology, you have the solar panel, the battery, because solars do have a battery inside of them. Most of the time it's a disposable type gel cell battery. So you got the power, the battery, the solar panel, and then the module, or the brains of the Energizer, which normally has some type of electronic circuitry in it that manages that relationship between the battery, the solar panel, and the Energizer itself. So add all those up, and you're going to pay more to get the same power out of a solar when you go to the farm counter to check out. Also, again, make sure you've got enough. Today, you may just need a little bit of power, but tomorrow you may have a little bit bigger load to pull, especially as you're adding to your fence system. And hopefully, if you're just starting out with some temporary fencing and managed grazing, that you will eventually add to that system and get a little higher level of management as the years go on and you see the results. Because we can see, of all the capital improvements we can make to our farming operation, when we start managing our grazing, that's probably one of the quickest capital improvements to see a return on when it comes to the pounds of meat that we're selling, or the quality of our soil and our forages. So joules is typically what Energizers are rated in. We don't rate in horsepower like you do with tractors and vehicles. We rate in joules. It's a hard figure. It's measurable, and that is equivalent to horsepower. The more joules you have, the more horsepower you have in your fence charger. The more load you can pull, the bigger load you can pull. The further you can pull that load is determined on how many joules you have. So we see a lot of different ratings for Energizers, and there's a lot of different estimates on how many joules will do how many miles of fence. So let's take in consideration mileage ratings and if they are accurate as they are stated on the box. So if we were to take a 4-mile Energizer, because you can go to the farm store and you can find one that'll do 4 miles or 25 miles or 100 miles. So let's just take a 4-mile Energizer. We should be able to take that 4-mile Energizer, if the marketing department of that company is telling us the truth, and we should take that Energizer out to Missouri where everything's laid off in big nice squares and find us a section of farmland that just happens to be 640 acres, which is 4 miles around the perimeter. We should be able to take that 4-mile Energizer somewhere out in Missouri, find a nice square farm of 640 acres, and effectively control cattle within that 640 acres, right? Sounds realistic for a $75 fence charger, doesn't it? So let's take it one step further. Let's go get the 100-mile fencer. Boy, it's a hot one. So we ought to be able to take it out to New Mexico on a 400,000 square acre ranch. So spend $300 or so, drive out to New Mexico, 400,000 acres. If I drive around a 400,000 square acre ranch, just so happens the perimeter is 100 miles, 25, 25, 25, 25. Realistically, am I going to spend $300 on a fence charger and electrify 400,000 square acres? Probably not. So what we do know is that within brands, you can compare those mileage ratings. Don't compare mileage ratings across brands because none of our marketing departments tell the truth. That's just the fact of the matter. Marketing departments are designed to do one of two things, or two things really: sell things and make things look pretty. Not necessarily to get into the details on the engineering behind it. So compare mileage ratings within brands, don't compare outside of brands, because there is no magic formula that companies use to determine how many joules per mile. And every company has a little different spec on it, and you can look at some companies that are made in New Zealand. There's 5 or 6 companies that will market in New Zealand and the US both. And surprisingly so, you can bring the same Energizer from New Zealand to the US, put it in US packaging, and it just instantly doubles in power. It doubles in the amount of miles it'll do, or it doubles in the amount of joules per mile it takes. So we know the companies they'll fib to us a little bit because they have marketing departments and that's their jobs. So let's say forget about the companies. Let's look at NRCS and extension. Several states have done quite a bit of research and real-world trials, and so we look at Missouri, extension. And Missouri, they were ones that I guess kind of literally wrote the book on the first electric fencing for serious grazers. Missouri says about a joule per mile. Fairly conservative, but they say about 1 joule or 1 horsepower per mile of fence. NRCS in Tennessee, similar situation. They agree with Missouri, but then California and Minnesota extension, 2 opposite ends of the country almost, they say, no, it's about 0.2 of a joule per mile. Then you have another company that kind of throws in the middle at 0.3 of a joule per mile. So the answer is nobody knows. And it depends. And it depends on how many strands of wire, how much weeds and grass, how many shorts, how much rusty wire you have, how many rusty wires you've got for jumper wires that are just loosely wrapped around when you come to a corner. So it depends on all of these factors of how many joules per mile we need. But what we do know is that the more joules you have, the more joules an Energizer is rated for, the more money you're going to pay. So just like a tractor, you're buying horsepower. With fence chargers, you're buying the joule rating. So proper wire selection. When I guess we're going to do a blend in this discussion of temporary and permanent. But from a conductivity standpoint, high tensile wire is going to be the most conductive, because if you think about it, the electricity travels around the outside circumference of the wire. The larger the wire, the more power I can carry for longer distances. And you have to step back and think. You think, well, a bigger wire would be harder to electrify, so I would need more power and couldn't go as further with it. But it's actually the opposite of it. If we look at it from an electrical theory standpoint, the more wire you have, the easier it is to electrify, because the power travels around the outside of the wire. So 12.5 gauge high tensile, that's kind of the gold standard, and that's matched up with resistance. So 12.5 gauge high tensile is about 56 ohms per mile of resistance. You do have a little better visibility with it than you would, say, your typical steel fence wire, which would be 14 or 17 gauge, especially because most of the 14 and 17 gauge temporary fence wire is going to rust after a couple years or so, because it's low carbon, so it's a soft wire, and typically we're not putting a whole lot of galvanization on that wire compared to high tensile. And all high tensile is class 3 galvanized. So high tensile is going to be kind of the gold standard for conductivity. You can get some high conductive poly wires. Every company is going to have a little different spin on their high conductive wires and the name of it and the color of it. But you can have a higher conductive poly wire and still not quite as conductive as high tensile. And then at the bottom of the list would be just plain old stainless steel poly wire. Every company makes this, and this is basically because we want to offer a low-cost alternative that's good for about 1,000 feet or less. So everybody's 6-strand stainless steel poly wire, once you get past 1,000 feet, you have so much resistance built up on the line, you can't push that power through to shock an animal. Now you may go 6,000 feet and go to the end of it with a voltmeter and test it and show 5,000 volts. Okay, that's good. University of Kentucky says 3,000 controls a cow. I've got 5,000. I should be able to shock the cow, and the cow walks right through the fence. That's because the cow loads the fence. The cow's walking around on 4 ground rods. That 6-strand stainless steel poly wire is around 11,000 ohms per mile compared to 56 ohms per mile with high tensile. So 11,000 ohms per mile, a lot of resistance. Cow touches the fence, she actually shorts it out. Voltage drops from 5,000 down to a couple of hundred. She doesn't get shocked. So keep that in mind. And also keep in mind color of your temporary fence products. And again, we're not going to use high tensile for temporary fence. This is made for a permanent application. I just wanted to mention that as kind of the gold standard from resistance. So real quick on color, you can find poly wires in umpteen different colors and shapes and sizes. There's one thing that is well agreed upon now by animal physiologists, and that is there is one color that cattle, sheep, goats, and horses can contrast better than any other color against a green grass background, and it is not this color. It is white. So white can be contrasted against green background in the summer, or even a dirty brown stockpile fescue background in the wintertime is white. Much better than a 17 gauge galvanized wire that hasn't rusted yet. And I guess we kind of learned this the hard way at grazing school, because we used to have reels to use for the field demonstration that you all did today. We used to have reels with different types of poly wire, poly tape, different colors, brands, whatever. And this actually came off of one of those reels about, what was it, Jeff, probably 10 years ago? Yeah, because every time, whatever group got lucky enough to get the black and yellow wire, then their cattle would not be where they left them the night before. So we finally just omitted this, and I kept a little section off of it just for nostalgia purposes. So black and yellow do not contrast against a green background or a brown background. Also, the conductivity between the two wires, in this case, you've got two wires here, made by the same manufacturer, look about the same from a distance, right? So this wire is 40 times more conductive than this wire. Now they're both white, they're both poly wire, they're both flexible, but resistance-wise, this one is 40 times more conductive because of the number of strands in the wire. This is a plain stainless steel stick strand, and this is a 9-strand blended metal. And there's different companies have little different blends of metal, but they take some of that stainless steel out and replace it with another type of metal to make it more conductive. You can go several miles with the high conductive poly wire. You can also get that in braids. Several manufacturers now make a braid. You can get a high conductive braid. This will let you go several thousands of feet or several miles in some cases of a poly wire system of temporary fence. So keep that in mind. 6-strand stainless steel is okay if you're going to do 1,000 feet or less, and that is strictly from an ohms and electrical resistance standpoint. Also with tapes, there was one group today that had tape, and tape is obviously much more visible. You can see that tomorrow when you walk back out in the field. Tape is a great training aid, in my opinion. I don't use tape at home, and we use quite a few reels for temporary fencing in the winter and summer both. And I try to use my tape reel just for training new cattle when we buy new heifers and bring them on the farm, just to get them used to it. There's nothing wrong with tape except for it does take more posts because you've got more weight, so you're going to have more sag between the posts. And also on a windy day, this is going to catch more wind. And then in the wintertime when we're grazing stockpile fescue for a couple of months, this is going to catch some ice if we do have those occasional ice storms like we get throughout Kentucky. And also with tape, same thing. You can get the high conductive tape and the regular stainless steel tape. Get the high conductive if you're going to use more than about 600 foot of the tape. So, Dr. Torch, you watching the time for me?
20 minutes.
Okay. So resistance, and I just want to mention this to give you a little quip on the permanent fencing side. We're not going to get into permanent fencing. If you want to get into permanent fencing, then UK has 2 permanent fencing schools, usually in the fall and 2 in the spring. That'll be out in your newsletter, and Dr. Torch coordinates that, and we cover all things permanent fencing, just like you saw in the field today, the fixed knot woven wire and the multi-strand electric. But on resistance from a permanent side, if one strand of high tensile is 56 ohms per mile, then electrical theory tells us that multiple strands of high tensile carry power for longer distances. As a matter of fact, as long as those wires are paralleled, so if I have 4 strands and they're just joined at one end, 1, 2, 3, 4, then I can quadruple my conductivity by going to the other end of that stretch and joining them again, 1, 2, 3, 4. So jump them up and down at both ends of the stretch. When I do that, it lowers my resistance instantly, going from 56 ohms per mile to 14 ohms per mile. I want 0. I want no resistance. So multiple strands carry power for longer distances. Very, very cheap, easy way to get more conductivity on a permanent fence setup. Lead out, don't let that be your weak link, and the lead out wire can simply be that 3-foot stretch of wire that goes from the fence charger to the fence itself. If that is a rusty piece of 17 gauge wire, then we're already slowing our electricity down through that rust. If it is a piece of copper Romex house wire that we had left over from when we built the tool shed, then that copper wire joined to our galvanized high tensile will corrode because 2 dissimilar metals with electricity running through them do not mix very well. So use the same material lead out as you have for your wire itself. So high tensile wire, use galvanized lead out for your galvanized high tensile. Temporary post options, you got to experience several of those today in the field. Keep in mind 1 strand or multiple strands. For sheep and goats, then some producers actually get by with 2 strands of polywire, of the high conductive polywire, to control sheep and goats. Some producers will say, nope, you've got to have 3 to control sheep and goats, and also add a little predator control aspect to it as well. With cattle, for the most part, single strand nose level, which happens to be the height of the top on all of the posts we use today, or the top of these ring top or pigtail type designs. Anything is better than packing around a 2-pound sledge and a rebar post and having to deal with insulators. So we wanted to make it easy and quick, so we're more inclined to actually go out and move our fences and rotate our pastures. So it's all about convenience and also usability. Usually we show a tumble wheel. These are great for stockpile grazing, but we didn't have one set up today out of the Master Grazer trailer. But tumble wheel is just another tool for a single strand. These things actually roll across the field. When they roll, this little metal plate here is activated by gravity, and it heats up all the legs except the 2 that are on the ground. So every time it turns, the bottom legs are insulated. But great for moving a single fence when you're not worried so much about back fencing cattle like we do in stockpile fescue. Reels. Today, the reels you used all had a hand guard on them, and they also had a wire guide on the front of them. That's simply a convenience factor. You can get plain old Econo reels from just about every company that have the same functions, except they will not be geared. So the ones you're using are geared. You turn the reel 1 time, the spool spins 3. But you can get plain old economy type reels that'll do the same job of holding the wire. You just lose a few features. One thing that is discouraged if you're moving wire regularly, then try to stay away from the temptation of going to buying a $15 cord reel from the hardware store. That may be okay to store wire on, but those $15 cord reels will deteriorate in the sun and break like a pie crust after they've been out in the weather for 1 season. So proper grounding. Choose the right power, choose enough power, and also use the correct type of wire. And those are pretty simple steps you can take because we are talking about a low-tech type simple fence. Don't take shortcuts. So number 1 rule, if you can avoid metal T-posts in your electric fencing situation in any way possible, avoid metal T-posts. Just stay away from them. Metal T-posts are an accident waiting to happen. We could have used metal T-posts today for the corners, but we didn't. We used the fiberglass post because the fiberglass post, there's no way to short that out. There's no way for the wire to short out on the post itself. But if you do use metal T-post, then you probably are expecting it to be very temporary, and you'll be okay with having some train wrecks along the way. So make sure you buy the cheapest insulators you can buy for the metal T-post so they break and everything shorts out quick, and you can fix all your faults at one time. So this is not a recommended payout spinner, a recommended temporary fence reel. Although it does work, but it works one time. So you probably won't be encouraged to go unspool that again to move your cattle to another pasture when it comes grazing season next year. We can do some things with overpowering for our fence system. We cannot perform miracles. So you will have to do some type of maintenance, whether it's mechanical or chemical. Don't let honeysuckles and poke weeds and multiflora roses grow up on your fence system and expect it to still work. So you're going to have to do some maintenance. And also, just some common sense things on insulators, the types of insulators and how deep we have to drive the staples to hold it. And if we don't drive the staples long enough, deep enough, the insulator falls out of place, then we have issues. And just, have y'all ever seen anything like this before? So we've got all kinds of things going on here. We've got a gate handle that's probably going to shock us the next time we grab it. And we've got this rusty wire that just happens to be what we're using to conduct our electricity through. Stay away from rust. If you can at all possible avoid anything that is not class 3 galvanized in your fence system, stay away from anything that will rust on you. And of course the Texas corner insulator. Bracing, we get into bracing pretty deep in the actual permanent fence school, so I'm not going to dwell on that because it's a half-a-day conversation. So if you're using kind of a multi-layered approach, then you use permanent fence as your backbone of the operation. So use that to distribute your power around with cross fencing like are in the paddocks at the research farm, and then use temporary for your flexibility to make your moves in between. Now, there is a slight compromise between permanent and purely temporary, and that is electric offset fences. And when you go back out there tomorrow, look at the end of your paddocks where the gate handle was hooked into when you left. That is hooked onto an offset fence. And what we've done there is we've taken that physical barrier of fixed knot woven wire and we've added a single strand of electrified high tensile to it, and we've created an offset. We've done two things with that. We've protected that woven wire fence, and we've also given ourselves an extension cord, which is what we use today. We have that extension cord we plug the gate handle into and electrified our fence. And it also keeps things like this from happening. Cattle, they will pressure permanent fences. Sheep and goats, for you all that are small ruminant producers, you've seen this happen. We can completely eliminate that with a proper built offset. And then think about some of if you're constructing a new cross fence or boundary fence, and think about some of the methods of why you do things. We are tempted to put a barbed wire on top a lot of the time. Nobody really knows why they put a barbed wire on top, but they put a barbed wire on top, and the cattle and the sheep and the goats, they still scratch right here at rump level and just completely ignore the barbed wire on top. So if you have horses or giraffes, put the barbed wire on top because it will discourage. Well, sometimes it does. Sometimes the horses scratch on it too. So we could probably do a lot more good with this fence by putting our electrified wire somewhere here at nose level or rump level on our animals instead of wasting some steel at the top. So offsets come in many different shapes and sizes. On the farm today, you saw a 12-inch offset that attached directly to the wire itself, which is a great option for older fences because older woven wire tends to bag and sag and move around. And when it moves around, then our electrified wire can move with it. Now, alternatives would be some type of a plastic offset 3, 4, 6 inches away from our woven wire background here. I don't like plastic offsets of any type for electrified high tensile just because there is quite a bit of weight on that. And it doesn't matter if you're buying the cheapest insulator or even the heavy UV stabilized heavy duty insulators. I'm just not a big fan of plastic for offsets because there's plenty other alternatives from several different manufacturers, one being either a ring top or a pigtail type design. You can get these in several different shapes and colors from different organizations that'll either be 6 inches or 10 inches or even up to 15 inches. These drive into a wooden post, so you have to have wooden posts to use those. But if you have wooden posts, then you've got about a 6-inch separation. It's a fairly rigid design. But ultimately, the longer the offsets, the better. And with offset fencing, especially once you're in this 6-inch to 12-inch range, you don't have to put these very close together. So you can stretch an offset out If you're going 12 inches, you can stretch these out 45 to 60 foot apart, depending upon your terrain. 6 inches, you're pretty much limited to about 30 foot apart on a 6-inch type offset, but it's still going to protect that existing fence or your old fence. So that was probably the fastest and the quietest I've ever given a presentation. So don't take shortcuts. Design your system right the first time and have a little confidence in what you're doing, and realize that when you're using some type of temporary fencing, that it is going to show you a return on your investment pretty quick. And I would much rather spend times doing things like wondering why I've got a 6-year-old sitting on a mirror fount in his pajamas than I would go around chasing shorts and worrying about where my cattle are. So with that, I've got to leave and head east after this, so my contact information is in the books if you have any questions afterwards, and don't hesitate to reach out. And while Dr. Teutsch is getting his presentation pulled up, I'll mention one thing that was very important that we didn't talk about today, and that is splicing polywire. When you splice polywire, it's very tempting just to tie a knot in it and leave it alone. But you've got to think about what all's going on in that knot. In this case, that are trying to make a connection through that knot. And when those wires keep trying to make connection, I can have burning that occurs, my polywire melts in two. So a very easy way to splice polywire is tie whatever type of fancy knot you want to, take a lighter, melt the poly off of the wire until you get something that looks ugly like this. I've got a good knot. I've got 18 bare naked wires. Once they cool, I'm going to twist them together and I'm done. You don't have to use wire nuts and splice sleeves, and just take a lighter, melt the poly off the wire, twist the wires together, and you're done. This is going to be a very good electrical connection, and it's not going to be as apt to burn into. Oh. All right, here's the live one.